forward to the guide. Okay, perfect. Great. I'm going to let everybody in.
Super. Ooh.
Hello.
Hello, everyone. Just waiting for people to log in. We might give everybody a minute to join. Okay, so I'm just going to get started. Welcome, my name is Elizabeth O'Reilly and I'm the Irish Project Officer for CIEEM. So I'm delighted to have been able to work with the Irish Section Committee to put together this event today. We're hoping that this will be the first of a series that will run and we can have lunchtime chats at the end of every month. I'm just going to run through some technical things. This might be slightly different to some of the other CIEEM webinars you've attended, where you don't see yourself or you can't unmute or turn on and off your camera. So this is done on a different system, but I just ask that everybody keep themselves muted so we can have little disruption to our speaker here today. So we'll just keep everyone muted. And also you can turn on and off your camera. If you have your camera on, I would just say that we are recording this session. So if you don't want to see your face in the recording, I would leave your camera off or turn it off. Okay, hopefully the technology will stay with us today and we'll be able to have a smooth run of the session. I just like to offer huge thanks to Karen for being with us here today. Dr. Karen Bacon is a lecturer in plant ecology in the Department of Biology or Botany and Plant Sciences at the National University of Ireland, Galway. So we're delighted to have Karen here to chat with us today about non-chemical controls for the management of Japanese knotweed. So there will be times Karen will chat with us for about 25-30 minutes, and then there will be an opportunity for us to ask questions and engage with her at the end. With no further ado, you might be muted there, Karen, so maybe unmute yourself and share your screen and we'll kick off the talk.
Okay, so can you hear me now?
Yes, yeah.
Super. So let me just share my screen. Come on. There we go. Okay, this can that be seen?
Yes, yeah, that looks great, Karen, thanks.
Super, okay. So firstly, say thanks to Liz for helping to set this up and for inviting me to give this short talk. Excuse me. It's really nice to be here over the internet, obviously, with you all. It's a topic that I have gotten increasingly interested in over the last couple of years, Japanese knotweed and all of its reputation versus the reality, and then thinking about how to control it. So, sorry, excuse me one sec. So the first thing that I'm going to do in a second is I'm going to put up a question, and then Liz is going to put up a poll, and we're going to ask you to answer the poll. So there's a couple of these throughout the seminar, just to kind of get your thoughts on things as we go by. Usually if this was an in-person seminar, I'd just ask, but so this is the way that we're going to do it for this. So I'm going to talk to you about investigating non-chemical controls for management of Japanese knotweed, but I'm going to talk about the species a little more broadly first as well, and also kind of think about some of the reasons why people are scared of Japanese knotweed. So the first thing that I would like you to do is to answer this question. So hopefully a poll, there we go, poll 1 has just appeared there. So which of the following do you consider to be most problematic? So Japanese knotweed, Himalayan balsam, giant rhubarb, or giant hogweed? So I've just stuck with the kind of the common names there for simplicity. So I think we're going to give you about 20 seconds to answer that. And I realize that the question is somewhat vague. That is done on purpose because we're obviously going to talk about this as we go through this seminar. So give another couple of seconds. And then I don't know if Liz can share the results while we're, oh, you can, brilliant. Okay, so Japanese knotweed is the clear winner there, 54%, then Himalayan balsam, and then giant hogweed and giant rhubarb, which I have a soft spot for. I did my undergraduate thesis on it a long time ago, isn't really that troubling to anyone. So that's great. So we'll move on. So just kind of bear that in mind. So what I want you to do is kind of think, particularly the people who have said Japanese knotweed, why do you think Japanese knotweed? Why not giant hogweed? Why not Himalayan balsam? So think about that. All right, my slides don't want to change. There we go. Think about that as we move on. And we might come back to that towards the end. So I'm going to start off properly now just by discussing a brief history of Japanese knotweed and kind of where it's come from and what its spread is like today. So Japanese knotweed, formerly called Regeneration japonica, previously Fallopian japonica, is native to areas in Japan, Korea, and China. And it was introduced to Europe by Philip Franz von Siebold, who was a Bavarian physician, botanist, and traveller during the mid-1800s. And he brought, sent seeds of Japanese knotweed to the UK in the 1850s. And from there, it was propagated and spread. And the spread of it is quite something. So if we look at these maps here, this is from the BSBI website. They have a great tool for showing you records of plants in Britain and Ireland. And what you can see is that records from before 1930, it's still very well distributed, but it's not everywhere. And certainly there are areas, around London, Cornwall and Devon, and then a little up north as well in England, and a few spots in Ireland. But if we look then at the more recent data, you can see that it has spread dramatically, and it's represented in most hectads in both jurisdictions, with the exception of kind of parts of Scotland and some of Central and Western Ireland. So it has spread considerably over this time, and it has a significant range of impacts. Things like increasing flood risk in riparian habitats, reducing accessibility to sites, the creation of monodominant stands, reductions in local biodiversity, and modifications to nutrient cycles. And we could kind of go on about that as well. That's not its only range of effects. This is the distribution map for the species globally from GBIF. And you can see its native range here. And then we can start to see the ranges where it has become invasive, a little bit in Australia and New Zealand. It's becoming increasingly concerning in some areas in North America, and then the hotspots in Europe, particularly Britain and Ireland and some parts of continental Europe as well. So from a relatively small native range, this has spread considerably and is problematic in several areas globally. So it's a fast-growing herbaceous perennial. The plant in the UK and Ireland spreads via rhizomes, so it grows from its rhizomes, and it does not right now produce by seeds. So seed production is not currently an issue in Ireland or the UK, but there are concerns about hybridization as well, which I'm not going to go into today. It can regenerate from small fragments of rhizomes or shoots, and it's capable of exploiting small gaps to grow through, like many other plants, and that's something that I'll come back to. It's estimated that about 1.6 billion has been spent in the UK to try and control it and eradicate it, but it's obviously still very common, so it's not gone terribly well. And Japanese knotweed primarily invades disturbed habitats and can result in changes to invertebrate assemblages, biodiversity, and increased risk of flooding along riverways, as well as some of the other impacts that we mentioned before. It has a hell of a reputation for what is a herbaceous perennial plant. So these are some examples. These are all recent, so these are just things from a quick Google at the weekend. So an article there from the Sunday Times. The root of all evil, Japanese knotweed flourishes in a warm spring. Tipperary Council issues warning on Japanese knotweed, that's not as dramatic. Then a couple that says they've endured 5 years of hell and get imprisoned in their council house from the Mail. And then new build buyers being urged to be cautious of Japanese knotweed. So the media loves a Japanese knotweed story. And it's often full of puns as well. It's a very pun supportive species. So the media, once there's any interest, will raise its head again, and we'll get lots of these clusters of articles when someone has said something about Japanese knotweed, or maybe there's been some new research has come out. It gets picked up really easily in the media. But it's also has featured in fiction, and this is one of my favorite quotes about Japanese knotweed. And this is from a Jeffrey Archer book, A Prisoner of Birth, and this wonderful quote from it. If you don't destroy it, it will eat its way into the foundations of any building, even reinforced concrete, and 10 years later, without warning, the whole edifice comes tumbling down, leaving you with an insurance bill that would bankrupt most companies. In Osaka, Japanese knotweed destroyed an entire apartment block, which is how it acquired its name. So how do I get hold of some? Asks Danny. So Danny is he's not doing a nice thing. He's trying to cause trouble for someone, and he wants to use Japanese knotweed to do it. It's probably worth saying at this point that none of that is true at all. I imagine if you could use Japanese knotweed to have buildings completely collapse, that it probably would have been monetized and used in the construction industry at this stage. But I just think that's a particularly entertaining quote around this, and it highlights the way people are afraid of it as well. So again, a very quick Google at the weekend. These are just were the top stories when I Googled Japanese knotweed. And again, it's all kind of, fear and urging vigilance, and people should be very worried about it. And then if you Google something like Himalayan balsam, you see some of these pictures and you see warnings about direct and problematic physical damage to people that the plant can cause. So I would like to say, in my opinion, that the reputation of Japanese knotweed is significantly overblown, my opinion. So this is our second poll now, and I would like to ask you to answer that when Liz gets the poll up. So which of the following is most concerning regarding Japanese knotweed? That it can grow through concrete, the damage it can do to houses, its rhizomes regularly grow to 7 meters in length, or something else. So again, you get about 20 seconds to answer that poll, and then we will continue our discussion around it. We'll see what people have said. So the rhizome is growing to 7 meters long. So that's good, because that's the most sensible thing that is said there. So it can't grow through concrete because it's a plant. And damage that it can do to houses is really minimal. We're going to look at some of the evidence for that as well. And something else I think is really where people are going with discussions of Japanese knotweed these days. So yeah, plants can't grow directly through concrete. And this is one of these things. People have told me this on numerous occasions when I'm talking to people about Japanese knotweed. There is a real belief, particularly in the public, that this is something that it will just grow up through concrete without any effort at all. And that is obviously not the case, but it has been presented in that way in the media to a certain extent for a long time. It can grow through cracks, but so can grass. So that's not a reason to be too terribly concerned about it. And in terms of damaging built structures, we've looked at that, and it doesn't cause any more damage than most other plants, and actually quite a lot less than some others. So we'll look at a little bit of evidence for that in a minute. And the rhizomes, they can indeed grow over 7 meters in length, but that is not normal and it's not usual. So how do we know this? We looked. So at present in the UK, and this is something that we don't want to see move into Ireland, because we're trying to address it in the UK at the moment. If Japanese knotweed is found within 7 meters of a property, then there are lenders who will be very leery of giving a mortgage, and they'll often require an insurance-backed treatment plan before issuing a mortgage, which can be very expensive. Now, this is an ongoing conversation in the UK, and there was a parliamentary inquiry about it back in, I think it was January, actually not sure if it was January this year or last year, but fairly recently anyway. They're kind of moving forward with trying to deal with that. So this costs more money, obviously, and then there's additional stigma around the species, and that kind of then is a perpetuating cycle. Part of the issue was the suggestion that Japanese knotweed can cause damage to buildings, so it directly causes damage to buildings, and also that the rhizomes can spread quite far from the plant. So in 2018, myself and some colleagues looked at this. So the first thing is, one of the things that used to come up a lot was the idea of subsidence, that it could cause subsidence, and that's just not the case. For a start, that's linked very much to geology. So you need to be on the right kind of rock and the right kind of soil for that to be any kind of an issue. And we looked at this specifically in the UK, and you can see that only some areas, particularly in the east and south of the UK, are where there's a risk of subsidence. So, and even then, when you are looking at Japanese knotweed, it's a herbaceous plant. It doesn't take up as much water as, say, a tree, so it's just not going to be an issue. So what actual damage might it be associated with? So in the same study, we asked members of the Property Care Association and members of the Royal Institute of Chartered Surveyors who dealt with knotweed if they had noticed any damage in the last time they'd been dealing with knotweed. And they identified between 2 and 6% of properties affected with Japanese knotweed that had signs of some sort of structural or building damage. Now, we asked for that as a correlation. So we said, did you see knotweed and did you see damage? We weren't able to look at it as a direct causation. So whether or not the knotweed was causing that is highly debatable. So they're really maximum numbers. And it's unlikely that the knotweed was causing even that level of damage. Only 18% of the respondents noted problems with drains, and 50% noted problems with loss of amenity. So that is more of the issue nowadays, is that particularly when a treatment plan is in place, you can't go traipsing around it. So there's a loss of amenity, and that's a real problem. We also noted that Buddleia, in a case study of 68 very old, very damaged houses, was much more likely to be associated with damage than Japanese knotweed. So this idea that Japanese knotweed is directly causing damage to buildings, it's not any more than any other plant might do, and less than a lot of others. So there's this idea of the 7 meter rule. So that when you see a sprig or even a big clump or a small clump, people don't tend to differentiate, of Japanese knotweed, that the rhizomes will grow 7 meters out from where you can see the above ground matter. So we looked at that as well. So we separated this into small stands, which was where you had 4 meters squared or less of Japanese knotweed, so not atypical of, say, a small infestation in an urban area, and then ones that were larger, so above 4 meters squared. And we looked at the horizontal extent. We found that, generally speaking, the rhizomes were far, far shorter than that. So we didn't have any incidence of rhizomes being beyond about 4.8 meters, and that was one exceptional case in a large stand. And more generally, if you look at these boxes, the kind of the middle line in the box is the median, so the middle value. And below that is 50% of the data, and above that is 50% of the data. So what we can see here is that really 2.5 is where the top box is on the larger stand, and that encompasses 75% of all of the data points. So really, even in a large stand, The rhizomes don't tend to grow beyond 2.5 meters. If you wanted to be quite conservative about it, you could say 3 meters, but they're definitely not regularly getting to 7 meters. So they probably don't cause much damage anyway, but even if they did, they're not growing as far as people think they are. So knotweed, the idea that knotweed causes subsidence more than other plants, no. The idea that it causes damage to buildings via the rhizomes more than other plants, no. And the idea that knotweed usually has rhizomes of 7 meters, no. So all of these rumors, all of its reputation, when you actually look at it, it's just not that bad. Now, having said that, this is still a very problematic invasive species that needs to be controlled. We don't want to have it, going everywhere and growing rampantly everywhere. It's not good, and it's not something that we want to encourage. But the next question that we had to ask was, does it always need to be dealt with by herbicide? And what else could be done? So is there another way of dealing with Japanese knotweed other than herbicide treatments? There is a reason for asking this question, and that is that herbicides are very effective and they work very well, but they can have undesirable side effects. And at the moment, we are in the middle of a biodiversity crisis. There are huge numbers of plants that are threatened in terms of both climate change, but also because of invasive species. But there's also a wide range of other species, animal species, that are also being impacted by the biodiversity crisis. And herbicide in particular is being linked to some of those, such as pollinator decline. So we need to think about this in terms of sustainability going forward. So as a bit of an aside, there are two things that are happening today as well. One is the United Nations Summit on Biodiversity, which is discussing all of these issues around the biodiversity crisis. And also the State of the World's Plants and Fungi released their report today. And there's a conference that's free in October if anyone is interested. And that's looking at what we know about the situation for plants and fungi today. And that also includes
Oh, we seem to have gotten a frozen Karen. Let's see if I can get her back. Sorry about this, everyone. I'm just going to give Karen a ring and see if we can get her back. She lost her internet connection, so sorry about this. So sorry about this, everyone. Technology for you. It is supposed to be, though, lunchtime chats. Oh, sorry, this is Karen, sorry. But if you want to unmute yourself and talk about what Karen was just discussing, work away.
don't know if everybody can hear me. It's Will Woodrow here. I thought I might start something off just in case. It seems that if we're working around to the idea of non-chemical treatment, I was just wondering if there is anybody out there has actually had experience of using non-chemical treatment for Japanese knotweed, such as use of meshes or anything like that. If anyone could provide any ideas of what they've looked at and whether it's worked or not.
Thanks, Will, for jumping in. Karen has lost her home connection, is trying to connect through her phone now, so we'll give her a minute and see if this works for us.
I mean, some of the approaches I've heard of, and it was around 4 years ago, where somebody was using a grid mesh. Sorry, I see Karen's back there, so I'm going to retire now.
Sorry,
Karen, I was just trying to fill in a little bit.
Thank you. Sorry about that, folks. I'm having internet issues, of course, today, so it should be great fun when I'm trying to talk to the students later, but never mind. They'll be delighted if I disappear. So I was just saying about glycophosphate and that there are issues with this around its licensing. So essentially in Europe, in the EU, there's large concern that this could be carcinogenic, and there was a whole load of kind of shenanigans around reports, and it's actually quite interesting, the case itself. So if you're not familiar with it, there's a summary in the article that I have highlighted there, and it's worth a read. But the real concern is essentially that glyphosate may not be renewed in the EU in 2022. So if the biodiversity crisis doesn't do it for you as a reason to think about not using herbicides for control, then the potential removal of the most effective herbicide to deal with Japanese knotweed should. So I just said all of that. So what are the alternatives? So here I have another poll, so poll number 3. And what I want to know before we proceed is, are you concerned about the potential loss of the license of glyphosate in 2022? So is this something that you've thought about? Is it something that you're concerned about or not concerned about? And it would just be interesting to get your views on that. Okay, so let's see what people think. Yeah, okay, so that is a very, yeah, an interesting response there. So generally people are concerned about it being potentially banned, but recognize that there might be reasons for it to be banned, which is actually a much more positive response than the last time I asked this question. So that's really nice. So what else might we be able to do? So the first thing is to consider scale. So this is a really big knotweed infestation. So there was a small child in that, but I didn't want to show that part of it. But that blue line there is about the size of a 3-year-old child. And the whole thing altogether is over 2 meters. So this is substantial. This is a problem. These are different, okay? So neither of these are over 20 centimeters. So you would hope that it's clear that this situation is very different to these. Now, if you're in the UK, they're going to be treated the same if you're trying to buy or sell somewhere, which seems crazy to me. But this is something that we need to think about with this species, is that the situation on the left is really, really different to the two situations on the right. Now, if the two situations on the right are left alone, then they could become really problematic, particularly the one where on the grass, the extreme right, that has potential to spread. The one in the middle, there's less room maybe for that to become a huge problem. So what we wanted to know then was, how well does Japanese knotweed regenerate from different size fragments? Because this is also something that you hear a lot, that it can regenerate and regrow from the tiniest of fragments. Someone told me with a straight face that all you needed was something the size of the filing of your thumbnail, and that it could fly through the air. Obviously that's not true, but there is this perception again that it can regenerate from nothing almost. And the other thing we wanted to know was, how well could drying the material out work to reduce the risk? So this is work that was done by my master's student primarily, and we looked at 3 sites. The red and the blue, the 2 higher dots, are both sites in the north of England, where we had 2 years of herbicide treatment, and the yellow is an area where there had been no treatment at all, and they're all on roughly the same kind of soil and in very similar kind of environments. So we brought them back to the lab, and they were cut up, and what was sampled was 1 crown from, 10 crowns were sampled from each of the sites, and from those crowns 3 rhizomes were also sampled. The rhizomes were then cut into sections where you had no nodes, 1 node and 2 node for each of those 3 rhizome samples. And they were then planted up and allowed to grow for 60 days. And this is kind of just an example of what the setup in the lab looked like. The mass of all the plant material was weighed before it went in, and new growth was measured painstakingly by my student Monday to Friday for the 60-day growth period. And then he also counted the number of leaves at the end and took a variety of other measurements as well. So this was the normal growth period that you see in the literature for most species is between 28 and 30 days. So we doubled that just to give everything as much opportunity to grow as it could. They were all watered regularly. And they were all given little bits of fertilizer, I think 3 times during the experiment. And just if anyone's trying to figure out the weird buckets we had, yes, they were Halloween buckets because they were the perfect size and the cheapest available option for that experiment. So when we eventually got the data and looked at it, what we see here is the 2 sites on the top, Burnley and Rodley, were the ones that had herbicide treatment. And we had full crown regeneration success for Burnley. For Rodley, we were surprised that 2 of the crowns just didn't grow. I don't know what the problem was with them. And then in Huddersfield, which was the untreated site, we also had 100% regeneration from the full crowns. We also had regeneration from the rhizomes, where we had 2 nodes, and the rhizomes where we had 1 node, but this was slightly less in each case than the full crowns. We also got some very small regeneration from 1 crep, from 1 node in some of these samples. So this is an example of one of the really tiniest ones that managed to grow, but they didn't live. So they sprouted and then they died, usually within 2 weeks, these really tiny ones. What was particularly interesting, not surprising, but definitely interesting and good to have the data, was that once there's no nodes on the rhizomes, they don't regenerate. So we had no growth from that at all. So that was quite encouraging. So what we've seen from this is that mass has an impact on regeneration and regrowth potential. The larger fragments were more successful, they were more likely to regrow, and they regrew bigger plants as well. So the plants that grew from the crowns were quite big. 1 or 2 of them grew up as tall as the available room in the lab. The ones that grew from the rhizome fragments were much, much smaller. So that is kind of highlighting that the bigger the plant material that you're starting with, the more of an issue it's going to be if it regrows. Regeneration was also observed despite 2 years of herbicide treatment at 2 of the sites. Now, I think there's a bit of an issue there, in that I don't think the herbicide treatment was being done particularly well. But you know, that's not something that we were able to control. And no regeneration was observed for any of the rhizome fragments with 0 nodes. So treating small plants the same as bigger ones is not ideal, because you're not really dealing with the same problem. And even if you, for example, say you have a big plant and you dig out the crown and dispose of that properly, and there's some regrowth the next year, you're not dealing with the same kind of an issue. So over time, we could potentially look at reducing herbicide use in that way as well. So what we wanted to do really, though, is we wanted to see what would happen when we dried the plant material out. So we dried the plant material after it had been harvested at 60 days. And what we found was this kind of general trend. So these are looking at the crowns, these are looking at the biggest components, the biggest size category that we had for the plants. And what we can see here is the dry mass this is when you, between weighings, where you see less than a 10% decline in mass. And we can see that for the crowns, generally speaking, this was achieved around day 30 of these experiments. And they were pretty similar between the 3 different sites as well. We looked at this individually for the different categories of rhizome as well. And the smaller the material, the faster it dried out. So again, this is not particularly surprising, but it's good to have the data. So the dry mass for the rhizomes was usually for the 1 node or the 0 nodes was usually around 10 days. And for the 2 nodes, it was usually around 20 days, but it could be a little bit longer for some of the slightly larger ones. But they all dried out, and this was just left on the lab on a plastic sheet. It wasn't oven dried or anything like this, because we were trying to replicate what might be possible for people if you were kind of doing this in a non-lab environment. So once the dry weight was reached, we replanted, refertilized, and rewatered all of the rhizomes and the crowns. So they were all treated exactly the same way as they were in the beginning and given every opportunity to grow. They were left and looked after for another 60 days, and not one of them regrew or regenerated in any capacity at all. So in this lab trial, desiccation was 100% successful at preventing regeneration or regrowth from size fragments across both the treated and the non-treated sites. So this is something that you could look at with small, obviously not with a giant field of knotweed, but with smaller, and again, thinking particularly kind of urban infestations. This is potentially a way to reduce herbicide use. Either maybe you apply it only once and then work towards digging the material out when it's smaller and easier to handle, and desiccate it. So I want you to ask you now, as the last poll, if you had a small infestation of Japanese knotweed on your own property, would you try this or would you not? And bearing in mind that it would all have to be disposed of legally in the way that your current, whatever jurisdiction you're in, there are different rules. So you do have to be mindful of that. Okay, that's really positive. That's not necessarily what I was expecting people to say, so that's good. And a few people, I fully understand the people saying they would just get a contractor, because yeah, I can completely understand that. And other people not so keen on the approach. That's okay. So essentially what we are suggesting is that for smaller infestations, a mixture of herbicides, so reducing the overall yield of herbicide that would be going into the ecosystems, and then desiccation could actually be quite effective. Very small ones, maybe just desiccation would be effective. This would reduce the cost of the treatment, and the desiccated remains could potentially be used for other purposes. Now, unfortunately, this is something that we were hoping to trial the summer just gone, but obviously all fieldwork and research has been paused for most of the summer, and we missed the season. So what we intend to do is to try this in 2021, and what we'll do is we will desiccate the material and we'll replant it. So that's the key issue here is whether in the field, whether desiccation is as successful. It should be. There's no biological reason that it shouldn't, but we definitely need to test it and see how it works. So we have a site where we're going to hopefully do that next year. And then we'll be a bit more confident in saying that, you know, you could, in theory, dry it out, replant it, let it degrade, let the nutrients go back into your garden or the ecosystem, wherever it is. Other alternatives would be for bigger masses, if you've dried them out and you're quite confident that they're not going to regenerate, would be reusing them in other ways for various reasons. So Japanese knotweed then is problematic, but not as much as its reputation would suggest. There are good reasons to want to control it, but herbicide need not be the only component to that, particularly, as I say, for smaller infestations. Maybe we don't need to use herbicide quite as much as we're doing now. And desiccation offers a potential solution for small to medium scale infestations. So thank you for listening to me, and I'm very happy to answer any questions, assuming I keep my internet.
Thanks a million, Karen. So yeah, there's time now. If anybody has any questions, you can write them in the chat. We can put them to Karen, or if you'd like to directly ask Karen, I just ask if you raise your hand, and then I can unmute and turn on, well, I can unmute and you can turn on your own video if that's what you want. So yeah, if anyone has any questions.
So how would desiccation be achieved in an urban setting? So I guess it would depend, and I think this is one of the things that once we know what happens when we replant it, we'd be looking towards kind of developing a set of protocols and advice around it. But quite simply, if you have, you know, a path, or if you have, I mean, I would probably recommend that, you know, inside, if you have a shed or something like that, just lay down a plastic bag, put your material on it, leave it there for, I think at the moment, the paper that's in review at the moment, we're recommending 70 days or something like that, which is double the period that we gave in the lab. So it's giving this massive extra padding to it. And then, you know, if you have a scales, weigh it before and after. But really, it should just be as simple as putting it somewhere dry where it's not going to get damp, and then just leaving it there for a while. And that should be sufficient then to desiccate it. We did it. So the question is it just the crowns that you desiccated, or the rhizomes? In a real life scenario, do you anticipate having to desiccate the entire rhizome to achieve no regrowth? So the crowns are the critical part. So if you can dig out and desiccate the crown, you will still probably get regrowth from the rhizomes. It depends on size as well. So if you've got a big rhizome network, then taking the crown out will help, but it's not going to get rid of it. But if you have, say, a smallish crown with a smallish rhizome network, if you take the crown out, the following year you should have substantially less growth. So if you won't need as much herbicide maybe to give it a second hit, or you can, you know, if you're just living somewhere, you're not trying to sell your house, you just do it over a few years. There's plenty of plants that are a pain in the ass to deal with. You know, there's some euphorbs that you'll be pulling bits of them out for years before you actually get rid of them. But they're not considered as horrifying in a lot of the same ways. So I would say the crown is the critical bit, but if you could take more out, then great, because the more you take out and the more you desiccate, the less growth you're going to have in subsequent years.
Can I ask a question?
Yeah,
I can't raise my hand. It's Christian Dowell.
Hi.
Hi, this is fascinating. This is really good. I'm a garden designer and landscape designer, and I've worked with I've come across it a lot, but I've worked with a big urban patch at a homeless hostel. And they wanted to develop a garden, and when they went down the chemical route, all the companies were saying, well, you've got to leave it, treat it for years and years and years and years, and that was no good. So we took the approach of digging out what were quite considerable stands and leaving them to dry, and it was tremendously effective. Now I did then stem inject some of the regrowth, and we were able to build the garden almost straight away. There are sporadic regrowths of it that I am now probably going to suggest is being dug up and dried. But the question is, I didn't get on the graph, you also measured the depth of the rhizomes of the larger patches. And I'm just interested that if there was an area where I could get a machine in and we could dig down and dig it out, what sort of depth might we be looking at?
Yeah, so depth is that. First of all, that's great to know. You've done one of my field trials for me. That's super. So you know, it's really good to know that has worked. And I think the issue with you know, the years long control, it's very, very effective. And if you follow what the you know, the contractors say, it works, but it is really high commitment as well.
Yeah,
and I think that digging it out is obviously manually can be really, really intensive. So you know, that's one of the other reasons to go with the herbicide treatment, is that it's faster in terms of applying it, and it's not as labor intensive. But if you have the time and you can do it yourself, then that's great. And I would just say, depending on where you are as well, it is considered controlled waste. So you do need to be careful about transporting it and moving it, and making sure you have whatever licenses are required depending on where you are. But the depth, so when we looked at the depth for small stands, the upper end was 2 meters, and for the bigger stands the average was about 1.75 meters. And then there was 1 or 2 of them that did go quite deep. They went down to 3.5 meters. So it can go down quite deep, but again, usually it's basically usually within 2 meters up to the side and down. But if you have a really big stand, that can be different. But usually it's not. It's usually within those kind of 2 meters, probably less if they're really small, to be honest, but kind of taking a conservative approach, 2 meters.
Yeah. Oh, okay. Yeah, no, thank you.
Great.
So I don't know if there's any other questions for Karen. Or any other comments?
Can I just one more? I don't want to hog it, but
Yeah, no, work away. That's brilliant.
The toxicity of the plant. My understanding is that it has no is not toxic in the sense of dangerous. Is there any information on the toxicity to humans, to mammals?
This is a really good question. It's actually, I'm laughing just because when we published the paper 2 years ago, people started sending me recipes. Actually, you can eat it. I do not recommend it. The last thing we want is people traipsing about and spreading it around more. But The Guardian a couple of years ago published 10 things you can do with Japanese knotweed or something weird like that, and they had you know, Japanese knotweed vodka and pie and all this kind of thing. So some people have reported that when they touch it, they get a tingling sensation, a bit of a rash. So some people can have an allergy to it. But in terms of being considered toxic, not usually.
Yeah, okay, thank you.
I have another question there from Rachel. Has there been any trials on council land? Not of this. So we started off with the lab trial so that we could then go to people and say, look, we're pretty sure that this is okay, and we want to try, because it's a big thing to ask, you know, a council or someone, you know, can we plant this massively problematic invasive species? Can we dig it up and replant it? And we're pretty sure it won't regrow. So we wanted to have the data before we approached people. We're working hopefully with other people on campus here in NUIG for the trials, and then we'll be hopefully branching out and asking councils for support once we can again give a little bit more reassurance, because it's not something that I want people to I want to be able to say that I'm as confident as I can be before I'm suggesting that, you know, councils try this. They've very limited resources, so we want to be as sure as we can be before we go into those kind of trials. Would I be able to send a link to the papers? Yes, of course. One of the papers is published. It's in PeerJ, and it's freely available. I can send a link to that, no problem. The other one, I'm afraid, is in review. So you've gotten hot off the presses information. I don't anticipate it being published maybe by the end of the year if we were very lucky, but early 2021 is what I'm hoping for. Oh yeah, the biological control agents. So the other question here is, I keep hearing in the press about trials of various biological control agents for Japanese knotweed. Is this something you've ever tried or had experience of? Biological control agents are really interesting. And there is, I know there's one being trialed in the UK on Himalayan balsam that is looking really, really positive. I can't remember what it is actually, but I know I've spoken to one of the women who's running it, and I just can't remember what the biological control agent is, but it's looking very positive, and I think they're hoping to move that forward soon. For Japanese knotweed, it's a little bit more complicated, and there have been a series of trials with very mixed results. And there was a paper out this year that looked at, I think it was some kind of insect, but there have also been trials on a fungus. Biological control agents can be very effective, but they're also quite high risk because you need to be really, really, really sure that it's only going to go at your target species and that it's not going to cause huge problems for other species in the ecosystems. So they tend to take quite a long time to be trialed, so that, you know, people can be, again, confident that they're not going to solve one problem and cause a much, much bigger problem. So yeah, there are trials ongoing, but for Japanese knotweed, as far as I know, there's a couple that are considered to be potentially good, but there's nothing that has been particularly well nailed down, I think. If anybody wants it, I'm just getting the link now. That's the published paper, which looked at rhizome extent, damage to buildings, and subsidence risk. That's a UK focused paper, but everything in it applies in Ireland as well.
Karen, do you mind if I just raise something? It's Will Woodrow here, just to raise something rather than ask a question, simply sure. Because Christian a little while ago talked about stem injection. Just to make sure that everybody is aware of the sustainable use of pesticides regulations. Yep. That, for example, require that any use of pesticides near water have to be in accordance with the label and of the herbicide. And Roundup, for example, which is the most common form, I guess, of glyphosate, specifically states that it's a foliar spray. So just people, it's worth people being aware of that there are complexities there.
Yeah, and thanks for raising that. It's a really good point. That yeah, it's not necessarily just go out and, you know, have a go with it. These are things that need to be used with care and following instructions. Yeah, it's a really good point.
Okay, I think last chance for everybody to pipe up if they have any questions, but I think we're getting close to the end of lunchtime anyway, and we might wrap it up there. But I just, a huge thank you to yourself, Karen. That was great and very informative. And we had some good questions there. And I'll just to say that we did record this session. We will be making it available on the website. We'll send the link around to everybody. And I'll also include the link to that article that you shared there as well, Karen. Okay.
Great. Thanks very much for having me. Sorry I disappeared midway through, but it was very nice to have the opportunity to chat to everyone, and everyone as well. I'm easy enough to find, so if you want to, if the link to the paper disappears or something, you know, feel free to give me a shout.
Perfect. Thank you very much, Karen. Thanks everybody.